Okay, good morning class. So today we're completing the cycle test 2 of July 2020. This is a substitute for the June exam. And this was the covered period. Okay. The question paper and memo can be found in the description box below. So this was the June exam on 5.2. No? Did we finish 5.1? Yeah. We're on 5.2. We are told that O is the center of the circle with radius 1. So O is the center of the circle, radius 1. So there goes 1, 1. OD is perpendicular to AB at C. Then we are told that BC is P. But remember, OD is also 1. Not so? Because that's your radius. So this would be 1 minus P for OC. We are told that O1 is equal to O2, which is equal to theta. Whatever is given there is now transferred onto the diagram. Okay? First question. Give a reason for your answer. So it's as if you're busy with Euclidean. Prove that P1 or angle OP is equal to. Must prove that P is equal to 1 minus cos theta. So if you're looking at where theta lies, theta is here. Cos is adjacent over hypotenuse. Not so. So we know that OC is equal to 1 minus P. Why? Because the OD is your radius. Okay. So cos of theta is equal to adjacent of hypotenuse. So it's going to be OP over, OC, not OP, OC over OB. But OC's length is 1 minus P over OB, which is 1, is cos of theta. Okay? So what do? We cross multiply. So cos theta is equal to 1 minus P. Make P the subject, so P is equal to 1 minus cos of theta. Okay? You look at 5.2. 5.2 says, prove that AB can be written as. What does that mean? Okay. We look at AB. AB is this length here. Not so. So, we know that if we got CB, CB's length is the same as AC's length. Why? Perpendicular from center to chord by sixth chord. Not so. So, I'm going to calculate CB. So it's either I can apply Pythagoras, because I know that this length here is 1 minus P. But there's no P here. So I'm going to rather go with opposite and hypotenuse, which is sine. So I say sine of theta equals CB over 1, which is OB. Okay? So we got sine of theta is equal to CB over 1. So in other words, CB sine of theta. Not so? So therefore AB is twice CB, which is sine of theta. Why? Because perpendicular from center to chord by sixth chord. And that's your first theorem of Euclidean geometry, which we did in grade 11. Okay? It was fairly simple. So this has Euclidean and heights and distances, or your geometry and your trigonometry. Well, let's look at number 6. Question 6.1. If f of x equal to 2x minus x squared, determine f prime x from first principles. So I must apply the whole story. F prime x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So remember, if f of x was equal to 2x minus x squared, then f of x plus h, simply going to give you 2 into x plus h minus x plus h squared. So I'm going to do my first point of simplifying here. So I say the limit as h approaches 0, f of x plus h, which is that there, I'm multiplying this 2 out, which is going to give me 2x plus 2h minus first term squared, it's going to give you x squared, which is negative x squared, x times h times 2 is 2xh, times the negative is negative 2xh. The last term squared, of course, is h squared, which is minus h squared. So that's the f of x plus h minus the story here goes in the bracket, which is 2x minus x squared all over. Okay. So what we do now, people? Get rid of the bracket. If you multiply, this is going to give you negative 2x plus 2x will cancel, and that is positive x squared and negative x squared cancel. Okay, otherwise you can write the story out and then you will see it cancelling there if you don't see it straight away. So we say now the limit as h approaches 0. I'm going to take out h as a common factor from the terms that are left. Okay, so it's going to be h, then I'm left with 2 minus 2x minus h all over h. So what happens? H is cancelled, so I say the limit at h approaches 0. Wherever I see a h up there, 0. So it's 2 minus 2x. And we can test by using the rules of differentiation. That would have been 2 minus 2x. That's correct. Sorry about this, I never wrote this here. It should not be written. Once you do the substitution, you drop this here. Also, if I had left this here, I would have lost the mark in my exam. Okay, and if I have lifted this out, this limit story out here, I would have also lost the mark. Okay, so it's very important to write the whole story. Okay? Is there any confusion there? Other than why do they give you so many marks for doing this? No? Shame. They could keep 3 of the marks and just give us 2. So we know what the answer is going to be. No point? She says yes. Alright. How did the what's the name section go? Nice. Full marks. I'll mark it now and let you know. Alright. dy over dx if xy is 3. People, what's the problem here? We must make x y the subject of it. Because that's dy dx. If it was the x dy, then x had to be the subject of the formula. You guys understand? So what I do is I divide both sides by x. So that cancels. So y is equal to 3 over x. But remember, we want it in the form of ax to the exponent n. That's the form we wanted. So what do? I bring that up. So now I have y is equal to 3x minus 1. So hang on. I got it in the form I needed to be in now. Now I can apply dy dx. Not so. So the derivative of y with respect to x is equal to be negative 3x minus 2. Remember, the exponent gets multiplied by the coefficient and a minus 1. So I can leave it like that, or I can write it as negative 3 over x squared. Either or get you the mark. Okay. But if you don't know how to do this and you're bringing the 3 down, rather leave it like this. Because if you're going to bring the 3 down and say negative 1 over 3x squared, you're going to lose a mark. Okay. But people, this only applies to the x. So only the x comes down. Okay. 6.2.2. Big D of x. Capital D, whatever. We are given the cube root of the square root of x, derivative with respect to x of the cube root of x squared minus 2x5 plus 1 all over x squared. So what do? I put each one over its own. Why do I want to do that? Because I want it in the form of ax to the exponent n. Okay. If it's not in that form, we must get it in that form. We can't apply the derivative to the top and then to the bottom separate. It doesn't work like that. Okay. When you go into university, you will learn how the quotient rule. Exciting times. No? And then you're going to learn how you can do the derivative of this. Okay. So let's get it in that form. We put each one of its own first. I'm going to convert that to exponential as well. So that's going to give you x to the 2 over 3 over x squared minus 2x5 over x squared plus 1 over x squared. Now I know some of you can do that in your head. Do it in your head when you're busy with studying for the exam. But in the exam, if I'm you, I would write these things out nicely. Okay? Because you guys normally have an hour left in your exams. No? No, not actually. Alright, d of x. So it's going to be x. What's 2/3 minus 2? Negative. 6 is 4 over 3. Check if that's correct. Remember, there's more in the denominator. So I can write it as 1 over x to the exponent 4 over 3 and then bring it up. Because I know I needed to be in the numerator, I'm going to bring it up one time. Minus. So that's going to give us 2. x5 over x squared is going to give you x cubed plus. Bring that one up. Becomes x minus 2. And now since I got it in the form I needed to be in, I'm going to apply the derivative. And what do? I drop this. Okay? Which is going to give us now, we multiply the exponent with the coefficient. So it's going to be negative 4 over 3x, and a minus 1 on this is going to give you 7, negative 7 over 3. Again, the coefficient with the exponent, so it's negative 6, you multiply, minus 1 gives me 2, negative 2 with the coefficient is negative 2x, minus 1 is negative 3. So with that, I can now say, I don't have to say this yet. So it's going to be negative 4 over 3x, 9 over 3, or 7 over 3, sorry. Minus 6x squared, minus 2 over x cubed. Is that correct? Okay, again, as I said this year, you don't need to. But I know some people always write it with positive exponents. So I'll give that answer here as well. Okay. But again, that is optional. And there's a question now clearly state, write with positive exponents, which just doesn't say it. Okay. People 6.3, I don't think you guys have gotten one like this before. So I'll make a mission to get you one. You haven't seen one like this yet, no? Right, here's your chance, your opportunity. We have seen draw a rough sketch of g of x equals ax cubed plus bx squared plus cx plus d. Where people, if it says rough sketch, it doesn't mean draw ugly. No. Okay. People, what type of graph is this? Quadratic? Oh, not quadratic. X to the power 3 makes the cubic function. So if A, the leading coefficient, is greater than 0, the graph, which means to say positive, the graph goes up then down. If A is less than 0, the graph goes down then. Not so. So which one applies here? The first one. So that is the shape of that graph. Could look like that or like that. No? You all agree with that? Where the turning point or the axis, the point of inflection is at that point. Okay. Then we are told in the second bullet that g prime x, what is this to us? G dash x, the derivative of g, what is this? The what? First derivative, yes, but what does it tell us? Well, what is the general gradient there, anywhere along the curve? So the gradient is greater than 0, which means the gradient is positive. When x is less than negative 1 and x is greater than 3 over 5. The name is supposed to have been O. Yeah, it must be O actually. I made a mistake there. So the gradient must be greater than 0. What does that mean to say? The graph must be? If the gradient is positive, what do we know? The graph is increasing. So if you look here, the graph increases, decreases, increases. And where does it change from increasing to decreasing? On the turning points. Can you see that, people? Okay. So this point here is where x is equal to negative 1. And this is where x is equal to 5 over 3. Can you all see that? Let's read it again. The gradient is increasing for x is less than negative 1. Can you see that? And the gradient is? The gradient is? Increasing for x is more than 5 over 3. Can you see that? So I can actually draw my x-axis here. That's your x-axis. And this of course is negative 1. And this is 5 over 3 here. Okay. Then g of negative 1 is 0. What does that mean? A g dash of negative 1. So g dash is your first derivative. When do I say the first derivative equal to 0? Turning point. So where's the turning point? Negative 1. Which is confirmed there. That is the turning point. Okay? This is also a turning point here, not so? Right? 1 of the x-intercepts is minus 1. Minus 1 is coming in a lot, no? People, what does that mean if one of the x-intercepts is minus 1? What does that mean? The turning point is on the x-axis. This is basically what it means. You guys understand? Easy. No? Minus 1 there. And then g of 0 is minus 3. When do we let x equal to 0? Y-intercept. So your y-intercept is at minus 3. The two turning points happen actually more or less midway between. So that's your point of inflection is going to be there. So minus. So your y-intercept will be there. And this is going to be minus 3. But you guys understand? Easy. 4 marks for something. I can't believe they're giving you so many marks. No? What? Look out for it in your upcoming exam. Not for the same one, but one similar. Okay. Yeah, give you a present now. No? Party gift.
If you do like maths in university, can it come to you fixed classes?
Only for those who came to extra classes this year. Otherwise, I must teach you a lot of new stuff. Yeah, we tutor university. People, any confusion here? People, let's look at question 7. We are told the graph of f of x equals negative x cubed plus 3x squared plus 9x minus 27. And g of x is equal to 5x minus 15 are sketched below. Oh, wow. I almost thought I missed it. So let's just write in what will be hidden. F of x is equal to negative x cubed plus 3x squared plus 9x minus 27, while g of x is equal to 5x minus 15. Okay. Then we are told that A and B, let's make this a bit smaller. Then we are told that A and B are the x-intercepts. A and B are the x-intercepts, and C is the y-intercept of F. Right? B and D are turning points of F. B and D are turning points of F. It's further given that G and F, which is the two graphs, intersect at E. Right? More information, not on the graph. So it's going to be negative 2 and negative 25. And B. So the two x-intercepts are there. Right. First things first. Question says, determine the coordinates of A. Right, 7.1.1. The question says, this over a bit, OCD here. 7.1.1, the coordinates of A showing all calculations. Now some of you have that calculator that can do this easily. Now if you're showing no calculations, you can't get all the marks, of course. Okay. This is what we require you to indicate. So you go f of 1. Let's try 1 first. Let's get the calculator. So f of 1. So if I see an x, I put answer. So it's negative answer cubed. Plus 3 answer squared. Whoops. Plus 9 answer. Minus 27. Okay, and I'm substituting 1 in for the first attempt. I get negative 16. So is 1 a factor? X equal to 1? A solution, sorry? No. I go minus 1. Is negative 1 a solution? No. Let's go minus 2. Or 2, sorry. 2 a solution? Yes. No. Negative 2? Negative 2 a solution? No. 3. 3 a solution? Yes. So, what does that mean? That f of 3 is equal to 0. Therefore, x minus 3 is a factor. 1 more. Showing that. Okay. So you can manipulate the system. You write that, we give you 1 more. No? You know what I mean? Right. Now we're going to factorize. So we say f of x is equal to. I'm supposed to have written the x-intercepted y equal to 0, no? Does this bear any marks? No, of course not. No? So we say x minus 3. So x multiplied by what is? There's a negative there. It's causing problems in our lives. But we love it. Not so. So 0 is equal to negative x cubed plus 3x squared plus 9x minus 27. So what do I do first? Divide by negative 1. So 0 is equal to x cubed minus 3x squared minus 9x plus 27. So what do we do? We say x minus 3. Not so. X multiplied by what is x cubed? X squared. Negative 3 times what is positive 27? Negative 9. So we say, okay, what must be added? Kx. So let's check. We got negative 3x squared. How do we get x squared? Constant by x, so it's negative 3x squared plus x by x, so it's going to be kx squared. Must give you an answer of negative 3x squared. Take that over the equal sign, so kx squared is equal to 0. So k has to be 0. Okay. So what does that mean? That means to say therefore x minus 3 and x squared minus 9. Difference of two squares there. So x minus 3, x minus 3, x plus 3 equals 0. So x is equal to 3 or x is equal to minus 3. People, there's 2 in 1 solutions here. I don't write x equal to 3 twice now. And also because there's 2 solutions here, you see it's bouncing off that graph there, at that point. You guys understand? So here, your second mark. What was the question? Determine the coordinates of A. So I have to say A is going to be minus 3 and 0. Is your second mark. And I think the third one was here somewhere. Okay. So if you only wrote A is going to be negative 3, only 1 out of 3 marks. Okay. So we know that A is minus 3 and B is 3. Again, there's 2 in 1 solutions here, it bounces off the x-axis here. Okay. Well, let's look at 7.1.2. 7.1.2. Determine the coordinates of D. People, what is D? D is your turning point. How do we calculate turning point? First derivative is equal to 0. So it's going to be negative 3x squared plus 6x plus 9. So it's equal to 0, drop that. Divide by negative 3. Otherwise I can use a quadratic formula, completing the square or the silver calculator. So you're going to get x squared minus 2x minus 3 is equal to 0. Factorize the trinomial, x and x, 3 and 1, minus plus, x equal to 3 or x equal to negative 1. Why do I get 2 solutions? There's 2 turning points. Point at D and point at B, which explains that 3 again. Can you see that? So the D is negative 1. What do I do with that? Sub it into the original function. So f of negative 1 equals, should be a lower than negative 27 solution here. Can you see that? Why? Because that's lower than the C. Negative 1. Give me an answer of negative 32. Have I answered the question? No. Therefore D is negative 1 and negative 32. Alright, do you guys understand? Right. Let's carry on with our lives. Seven point 1.3. In 7.1.3, the question says for which value or values of x is f concave up. But concavity is dependent on second derivative. Not so. So if who? Weinberg. So thank you. So, my first derivative was negative 3x squared plus 6x plus 9. My second derivative is negative 6x plus 6. I say that equal to 0. Drop that. So negative 6x is equal to 6. Negative 6, so x is equal to 1. So your point of inflection happens there. At 1 and some y value. The question wasn't for the coordinates of the point of inflection. If it was, I would have substituted 1 into this equation here. Okay, and get the corresponding y value. But for concave up, will be this part of the graph. Not so. Here the graph is concave up. You all agree with that? So in other words, x has to be less than 1. You all agree with that? Therefore x is less than 1. 7.1.4. Determine the equation of the tangent of f at c. So here, point of the tangent. What's the coordinate of c? People, what is c? Y-intercept. How do you calculate y-intercept? X equal to 0. So what is f of 0? Negative 27. So what's the coordinates of c? 0 and negative 27. Right. So how do we calculate? Okay, well, the equation is of course a straight line in the form of y equals mx plus c. To calculate m, it's your first derivative. First derivative is general gradient anywhere along the point, along the curve. But it's at an x value of, what's your x value here? 0. So it's f prime of 0 equals. Put 0 in here, get an answer of 9. Which means to say the gradient of the tangent is 9. So y is equal to 9x plus c. Let's say, hang on. It's going through the y-intercept here at 0 and negative 27. So what's my c value of the tangent going through there? Negative 27. Can you see the same value? So we're going to say minus 27. Beautiful sum, no? Yeah, then again, all sums are beautiful. People, any confusion there? Not yet. Okay. So we need you ask the same question in the exam, then we are totally confused. Here 7.1.6. Nope. Now we are told if M is a point on G between if M is a point of G between E and B, N is a point on F, yes, and MN is parallel to your y-axis, or you could have said perpendicular to your x-axis. Give the algebraic representation of MN. Right, so this line here, they want you to give the algebraic representation of that line. So, looking up from top, we put the eyelashes there. Yes? Looking from on top, you must look where, which graph is on top. Not so. So for MN, is going to be your top graph, which is which? The g of x minus the graph at the bottom, which is f. Can you see that, people? What's the equation of f of x? Sorry, g of x? 5x minus 15 minus f of x, negative x cubed plus 3x squared plus 9x minus 27. So that gives you an answer of 5x minus 15 plus x cubed minus 3x squared minus 9x plus 27. Which is x cubed minus 3x squared minus 4x plus 12. Is that correct? Okay. And that is your algebraic expression for MN. Okay. If they ask you for the length of MN, then they would have to give you a value between -3 and 0. Any value between that. And then you substitute the x value in, and you get that length out. Okay. Question 7.2, we are told, determine the value of P if y is equal to px, y is equal to 2x plus P is a tangent to this curve. So let's just give you an idea of what we're looking at. If that is the curve, your parabola, your quadratic function, and we have positive gradient. So this is what we have. Okay. That point of contact is yeah. Okay. We don't have that point of contact. That's number one. But what do we have of this line? We have the gradient of this line. And okay, the y-intercept your p value, your constant. So how do we normally calculate this gradient? First derivative, and then we substitute your x value in to get that y value out, and the gradient out. Not so. However, here we got the gradient. So what we're going to do is, to get this x value, I'm going to say y prime or y dash or dy over dx is all the same thing. It's going to give us an answer of 4x minus 6. So that's my general gradient anywhere along the curve. Not so. If I substitute the x in, I will get the gradient out at that point. But we have the gradient. So I set the first derivative equal to the gradient. Can you see that? So you say the gradient is equal to 2, which is equal to 4x minus 6. So in other words, 4x is equal to 8. So x is equal to 2. So what does that tell us? That the parabola cuts the tangent at an x value of 2. Remember, I must solve for p, no? So I need a point on this graph. But what can we do with 2? Substitute it into the parabola's equation. By doing that, what we're going to get? Corresponding y value. Remember, if I put the x in, I'm going to get my y out. So now we substitute. X is equal to 2 into y is equal to 2x squared minus 6x plus 2. Wait. So I got 2 is equal to 2 times 2 squared, which is 8 minus 2 times 2 is 12. It's negative 4 plus 20 is 16. Just check if that's correct. Okay. So what does that tell us? The point of contact is 2 and 16. Now we can calculate P. What do you want to do now? We're going to substitute 2 and 16 into the tangent equation, which is y is equal to 2x plus P. Remembering, people, that this is an x and a y. So what do we have? 16 is equal to 2 times 2 plus P. That's 4. Take it over the equal sign. So 16 minus 4 is 12. So P is equal to 12. Huh? 6 marks. No. Imagine you didn't know this. 6 marks down the drain. But okay, you won't be that one. Alright. So it's getting sweeter and sweeter. Né? Let's go. Next. Question 8. We're nearing the end of the paper. So I can see the probability coming up now. 10 swimmers compete in a 100-meter backstroke race. In how many different ways can the first 6 places in the event be arranged, assuming that there are no dead heats? What's dead heats? ending at the same time. I think that would be considered digits. But okay, could be wrong. But okay, people, how many bits would I draw here? We're looking for 6 places. 6 bits. There's 1, 2, 3, 4, 5, 6. So how many options do I have for bit 1? Person coming 10th place. First place. 10. Give me the answer. Second place? 9. Third? 8. 7, 6, 5. You can just multiply this out, or I could have used the formula. Since there are 10 competitors for 6 placements. So it's going to be 10 minus 6 factorial. So it's going to be 10 factorial over 10 minus 6 factorial. Oops. Your answer? 151,200. Okay. People, if you didn't want to do that, of course you can say 10 times 9 times 8 times 7 times 6 times 5 times 5. Only till 5. Give you the same answer, 151,000. Okay. That's really simple, no? Right, let's look for something that's going to challenge us a bit more. Right, we all feel this, no? At some point in our life, we want to feel. Okay. 5 letters from the word special are arranged randomly with no repetition. What does no repetition mean? No letters are repeated. Okay. Determine the probability that the word spice is chosen. Spice. All things nice. No? Right. So let's go. Is there any repeated letters here? No. So the other formula doesn't kick in. Okay? The repeated letters are treated as identical letters. Alright? So, determine the probability that the word spice is chosen. So it's 1, 2, 3, 4, 5. Oh, 5 letters on this word. Okay. Okay, so the probability is equal to the number of favorable outcomes over number of possible outcomes. Okay, so your favorable outcomes is going to be 1. No? Possible outcomes? Simply going to be 5 liters. How many liters here? 7, eh? 1, 2, 3, 4, 5, 6, 7. So, if you've got the possible outcomes is 5. 1, 2, 3, 4, 5. How many options do we have here? How many options do we have for the first bit? If you're not considering the favorable. How many 5 letter words can be formed with this? 7 and then 6 then 5 then 4 then 3. Or you could have said 7 factorial over 7 minus 5 factorial. Okay. There's going to be 7 factorial over 7 minus 5, which is you could have just say 2 factorial. Gives you 1,000 to 1,000, 2,000, 500. I almost feel like I'm wrong. But anyway, it's 1 over 252. Is that correct? Huh? No, right. I felt what was that? I'm making a mistake. Right, what am I doing wrong? Sorry? Correct? 5 factorial over 7 factorial. 5 factorial over 7. Oh, yes, yes. Because I'm considering only the word spice. But it can be ECIPS as well. And it's all this variation. Yeah, so I'm wrong. Okay. So it's going to be 5 factorial over 7 factorial. Which is 1 over 40. Is that correct? Sorry about that. I think we got one sum left. Eh? Yeah, we'll do that in my next lesson. Have you chosen the next paper already? I'll send it to the group now. Okay. People enjoy the rest of your day. Morning class. The full paper can be found in the description box below. Okay, so in question 8.2 we are told how many 4-digit numbers. Hang on, you stay outside. Everybody is yelling. How many 4-digit numbers have no repeat digits, or repeated digits, do not contain 0, and have a sum of digits equal to 28? So we look at 4 digits, so it's going to be 4 bits. 1, 2, 3, 4. So if we look at numbers, it can be either 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not going to consider 0 because they said that none of the numbers can be 0. And I have a sum of digits equal to 28. So if I add these 4 numbers, it must give you an answer of 28. Alright? So what do we have? Pull this over. So if we choose the first number to be a 9, I told him now, just wait outside. 9, then 8, then 7. 9 plus 8 is 17, plus 7 is 24. Is that correct? 9 plus 8 plus 7 is 24. So the only number this can be is a 4. Okay. So that's one way I can get 24. So if we look at this combination of numbers, where are you going? Just wait outside, I will get you in now. Just hang on. Okay, so how many options do I have here? From these 4 numbers, it can be 4, 3, 2, then 1. So in other words, this can be written as 4 factorial. Okay. For those 4 digits. Then, of course, we could have gone with 9, 8. Instead of a 7, I could have gone with a 6. So 9 plus 8 is 17. And 17 plus 6 is 23. 23 plus what is 24? Why? Not so? So it's 10, 18, 24. So from these 4 numbers, we can rearrange that. And then we would get, how many options do we have here? 4, 3, 2, 1. Which is going to give us, again, 4 factorial. Okay. Let's go again. The numbers could have been 9, 8. We've tried 7, 6. Let's go with 5. So it's going to give you 17. 17 plus 2 is 22. So 9 plus, let's check here, 8 plus 5 is 22. The sum must be equal to 28. Did I go with 28 here? No, I went with 24. Yes. I think I did 24 on both. Not on both. Okay, so this is going to be 9, 17, 24. Right, so that first one is right. Let's go again with the second one. I'm going to think of 24 here. Okay, so 9 plus 8 is 17. 17 plus 6 is 23. 9 plus 8 plus 6 is 23. So what could this be? 5. So there's going to be 4 factorial. Right. I'm going to look at 28. No? 1, 2, 3, 4. Again, I could go 9, 8. I did 7, 6. Could be a 5. So let's see. 9 plus 8 is 17 plus 5 is 22. Correct? 9 plus 8 plus 5 is 22. So what could this be? It could only be a 6, no? Which means to say that is repeated. So could this be a 5? No. Let's try a 4. If that's going to be a 4, then this will be a 7. So that's not going to work. Alright. Let's try, so we went 4. So it's going to be 9, 8, 4, 3. So it's going to be 9 plus 8 plus 3 is 20. This has to be an 8, but I used the 8 already. So that's not going to work. We're going to put the 2 here. Then I've got 19. And 28 minus 19 is going to make that to be a 9. So that's also not going to work. Because otherwise it's repeated. So that's not going to work. I could start with the 8. So 8. Of course I'm not going to go with a 9. Because otherwise I would repeat this. So it's 8, 7, 6. So 8 plus 7 plus 6 plus 5 is 26. So the largest combination starting with the 8 is short already of 28. So no other numbers I choose here will be close to 28 even, or let alone 20. You guys see that? So the only combination that could happen is 9, 8, 7, 4, 9, 8, 6, 5. So in other words, the total number is going to be 4 factorial plus 4 factorial. So 4 factorial plus 4 factorial is an answer of 48. So there are 48 such combinations of 4-digit numbers that has no repeated digits, do not contain zeros, and have a sum of digits equal to 28. That brings us to the end of the June exam 2020. And the full question paper and memo can be found in the description box below.